Hey, 30-1s. What we're going to look at in this quick video are applications of trigonometric functions. Now, there's lots of applications of these. The sound of my voice right now is a sine wave. Average temperature over the course of a year, average hours of daylight, tides coming in and out of a harbor. What I'm going to look at here seems to be everyone's favorite application question for some reason, the Ferris wheel, because we all ride Ferris wheels every day. So we'll go through the Ferris wheel question, and really all the other applications are all the same. Now, first thing I need to note, on any application question, we are always in radian mode. Nowhere does it say that in the question. You must know we are in radian mode. Okay, so this one says we got a Ferris wheel for a radius of 10 meters, rotates every 60 seconds. So that's important. That's important. Okay, passengers get on board at 2 meters above the bottom. Right there. Okay, it's never at the very, very bottom, or else the Ferris wheel would hit the ground and we'd have a bit of a problem. Okay, and then it says write an equation. It doesn't tell us what equation to write. In fact, I'm going to write the same equation 4 different ways. Or I'm going to write 4 different equations for the same graph. It's probably a better thing to say. Now, before I do that, always draw a picture. Now, if I don't have a grid, I'm going to do this. This is time. This is height with respect to time, right? And then all I need to do is I just need to go through the info and see what it says. Well, we get on 2 meters above ground. So that's our minimum. And I'm just going to draw a dotted line here just so I know where I'm drawing my minimum values. Then what it tells me is my radius is 10 meters. Well, your radius is also your amplitude. So that's right there, 2 plus 10 is 12. That's going to give us our median line. Okay, I'm also going to just kind of draw that in because I love to draw my median line. So what I know now is I know D is 12 and I know my amplitude is 10. Well, I also know my max because it's my radius. It's my amplitude. So if the radius is 10, I'm going to go up another 10. So we've got a max at 22. All right, how do we draw the rest? Well, we start at the bottom, here at time 0. And it tells us in the question the period is 60 seconds. Now, always be careful about that. Sometimes they tell us it takes 60 seconds to rotate twice or 3 times. So just always watch for that question. They're trying to trick you if they do that. So in 60 seconds, I'm going to be back here at the minimum. That's all I need to draw this, because halfway between 2 minimums is 30 seconds. I'll be at a max right there. And here comes the next part. Halfway between a min and a max, I'm on my midline right there. And halfway between a max and a min, I'm on my midline right there. And there's one period of our graph. So it's going to come up and down just like that. And of course, we know this keeps going forever. There's your graph. So now let's make some equations of this. Well, we already know D and A. That's good news. But what about B and C? Well, to find B and C, all I'm going to do here is this. Well, B value, we know we have this handy little formula, is 2 pi divided by P. Well, my period is 60 seconds. So 2 over 60 simplifies to pi over 30. Don't be surprised to see that pi in the B value. It happens quite often in applications. Okay, so here we go. We've got A, B, and D. I'm going to leave C until the end. Let's start writing equations of these functions. So I'm going to do a sine. I'm going to do a cosine. And then I'm going to do a reflected sine. And I'm also going to do a reflected cosine. Okay, now all we need to do is sub in our values. Well, we know our amplitude is 10. That's A. That's the radius of the wheel. So that's the same for all of these. That's the nice thing about this, is once you figure these values out, the only value that's going to change for each of these four equations is the C value. Okay, when we know our B value, it's pi over 30. So I'm going to go and sub that into all of these. Like so. Okay, now I'm always going to build in factored form. It's time, so T for everything. Okay, I'm going to leave a bit of a gap there, close parentheses. Okay, I'm missing our C value. I'm going to come back and get C in just a minute. And our D value was 12. So what is that on the wheel? That's the center of the wheel above ground. Sometimes they call that the hub of the wheel. All right, so now all we got to do is find C. It's the only thing that changes for all four of these. All right, let's go back and look at the graph. A sine graph is what I'll do first. A sine graph starts on the midline going up. There's sine. A cosine graph starts at a max going down. There's cosine. So minus 15, minus 30. Now, that wasn't so bad. The last two, the reflections, okay, so a reflected sine and a reflected cosine. I'll go to, let's go pretty purple for that one. A reflected sine. Well, a reflected sine would mean I'm on the midline going down, right there. That's 45. The one that I want you to notice the most is this last one. Save the best for last. This one. Why do I like this one so much? Well, if a cosine graph usually starts at a max going down, a reflected cosine is going to start at a min going up. Look at where that is. On a Ferris wheel, I've never seen a Ferris wheel where I don't get on at the lowest point. Well, guess what? It's 0. I haven't shifted anywhere. There's no phase shift. Do I even need that 0? No, sir. I don't. That's why I like the reflected cosine for a Ferris wheel question, because we start at the bottom. We're at a minimum. There is no phase shift. There it is, friends. There's how you do an application question. Again, notice that we're in radians. So, just in case we get the Ferris wheel again, I always want you to just kind of remember these pieces. The A value, which is our amplitude, well, that's the radius of the wheel. Sometimes they give us diameter, so divide by 2. The D value is the center of the wheel above ground. It's also the average height of the rider. So as the rider goes around, their average height on this question would be 12 meters. We were probably in meters, right? And then we find the period, which gives us the B value using this. And then the C value, well, that depends on which type of function we're writing. There it is, friends. That is the world famous Ferris wheel question, because we all ride Ferris wheels every day. Hope that helped.